So in this video, we're going to talk about how you can use regressions and Desmos to write exponential functions and make predictions from a set of data. So sometimes the data in your scatter plot may have an exponential pattern. So in these cases, you'll need to write an exponential regression in order to model your data set. So the equation of data that represents an exponential trend can be found by performing an exponential regression in Desmos. Desmos will also tell you the coefficient of determination, which is r squared, and that'll tell you how well your equation fits your data. If your coefficient is closer to 1, that means your equation will be a good fit for the data. So you can see here I have a coefficient that's 0.9873. That means this equation is a very good fit for my data. So there's a study guide that has the steps to performing exponential regressions in the resource folder. Make sure that you're using it when you're working on finishing your assignments. So let's enter the data in this table into Desmos and apply an exponential regression to determine a function. Let's also use the coefficient of determination to determine how well our equation fits the data. So to do this, I'm going to start off by clicking this plus sign here, add item, and then I'm going to choose table. And what I'm going to do now is I'm going to go ahead and type all these values into my table exactly as they are given to me in the problem. Remember, it's always a good idea to stop for a minute and then double check and make sure that everything in your table exactly matches what's given in the problem. You're going to click this add regression button right here, and then you need to select exponential regression from the drop down menu. So down here, I have exponential regression. You can see it gives me the equation y equals 3 times 2 to the x. So that's going to be my exponential equation. You can see that r squared equals 1. So that's telling me that this equation is a perfect fit for this data. Okay, and that actually makes sense if I look at the graph because you can see that this equation does in fact pass through every single point in my scatter plot. So now you can go ahead and pause the video and try doing this example on your own. So if we go ahead and enter this data into Desmos, and then we do add regression and then choose exponential regression. You can see it gives me the equation 1000 times 0.5 to the x. R squared is 1, so that means this equation is a perfect fit for this data set. So here it says that Jill just finished making a large pot of soup. She needs to let it cool before she can put it in the refrigerator. She noted the temperature of the soup at time intervals after she made it and recorded the data in the table below. Let's write an exponential equation to model the temperature of the soup as a function of time. So I'm going to go ahead and do the plus sign and then choose table. And I'm going to type in all these values. And then I'm going to choose add regression. And then from the drop down menu, exponential. I'm going to go ahead and round the values in this equation. So I'm going to write this as y equals 200 times 0.90 to the x. Okay, you can see here the r squared is equal to 1. So that means this equation is actually a perfect fit for this data set. So regression equations can be used to also determine future values in real life situations. All you need to do is plug the value that you're given into the equation and solve for the missing variable. So let's revisit this example that we just did. So we remember found the equation for the temperature of the soup was y equals 200 times zero point 0.9 to the x. So what if this problem asks us to calculate the temperature of the soup 10 minutes after she makes it? Well, remember the time in minutes was the value of x, right? So this is basically saying take this equation, right? So if we replace this with f of x, we have this equation 200 times 0.90 to the x, and it's saying, well, find f of 10. Okay, and remember we can actually do this in Desmos. We could just go ahead and type in our equation, f of x equals 200 times zero point 0.9 to the x. And then in the next line, I'm going to go ahead and do f of 10. Okay, and you can see it gives me this value right here. I'm going to go ahead and round that. So that means that the temperature of the soup is about 70 degrees Fahrenheit. So here it says a new mother takes her baby to the doctor each month for a checkup. The baby gets weighed each time. The mother has data from these visits recorded in the table below. Write an exponential equation to model the data. Let's use the coefficient of determination to determine how well this equation fits our data and predict the weight of the baby at 15 months. So I'm going to go ahead and start off as usual by creating my table. And then I'm going to type in these data points. And so you can see here it's created my scatter plot, and then I choose add regression. And from the drop down menu, choose exponential regression. So I'm going to go ahead and plug this into my equation. So I have y equals 6.89 times 1.11 to the x. So you can see here the r squared is equal to 0.9873. That value is really close to 1. Okay, so since that value is really close to 1, I'm going to say this equation is a good fit for our data set. It also wants us to predict the weight of the baby at 15 months. So what I'm going to do is I'm going to rewrite this with f of x. So I have f of x equals 6.89 times 1.11 to the x. And then I'm going to ask it to evaluate now f of 15, right? Because when x is 15, that's the weight at 15 months. So you can see here this is 32.965. The data in my table is all rounded to the tenths place, so I'm just going to go ahead and round this also to the tenths place. So I have 33.0 pounds for the weight at 15 months. So now you can go ahead and pause the video and try doing this example on your own. So here it says John tracked the mouse population on his farm over 6 months. The data he observed are recorded in the table. Let's write an exponential equation to model the number of mice on his farm. So I'm going to do plus table, and then I'm going to type in all these values. And then I'm going to do add regression. And then from the drop down menu, choose exponential regression. I went ahead and rounded these values. So I have 6.94 times 1.4 to the x. Remember, I'm going to go ahead and rewrite this as f of x. So I have f of x equals 6.94 times 1.4 to the x. And then it's asking me the population on 10 months. So remember, months is the value of x. So this is basically saying now find the value of f of 10. So I'm going to go ahead and type this in Desmos. So I have f of x equals 6.94 times 1.4 to the x. And then we just ask it to find f of 10. And so that gives us 200.7. Since you can't have fractions or decimals of mice, I just went ahead and rounded it to the nearest whole number, which is 201.